Lesson 1, Unit 5. There's my first mistake of the day. Okay, factoring review. We talked about factoring in Unit 0, like boomerang. It came back in Unit 2, and it came back, well, now. So our big thing we want to remember is always take out the GCF first. This will make our life a lot easier. Okay? That's why here the first step is look for a GCF. Now there are some patterns in factoring, some shortcuts. The difference of two squares, when we have two perfect squares and they're being subtracted, we can break it up into a plus b, a minus b. For a sum of two squares, it's almost the exact same pattern. A plus b and a minus b. But we need the help of our little friend, I. Because if you think about it, go back to difference of two squares, positive b times negative b gives us negative b squared. So here, if we take a positive b times a negative b, we get negative b squared. But we want a positive b squared. Our imaginary numbers help us out there. Because if you remember, I squared equals negative 1. Therefore, that negative b squared times negative 1 ends up being our positive b squared that we need. Now for cubes, we got to remember the acronym SOAP. Same, opposite, always positive. So for difference of two cubes, it's going to be a, same, minus b. And then it's going to be a squared, opposite, a times b, always positive, b squared. Same setup down here, except since we're starting with a sum, same, a plus b, a squared, opposite, a times b, always positive. And there's our pattern. So, moving on to some examples. Hopefully you recognize that 25 is a perfect square. And 81 is a perfect square. I did that backwards. Also, if you see this 2 here, anytime an exponent's even, it's a perfect square. So the square root of x squared is x. The square root of x to the 4th is x squared. The square root of x to the 6th is x cubed. So we're looking for even exponents for the difference of two squares. And then we just break it down into the square root of the first term, square root of the last term, 1 plus, 1 minus, we're done. Now, see this little 3? That tells us we're looking at cubes, and it's a sum of cubes. So hopefully you recognize that 3 cubed is 27, and 4 cubed is 64. So we're going to do our SOAP pattern. Cube root of 27 is 3. And the next, there's our a term. SOAP, same. Cube root of 64 is 4. Now, a squared, 3 squared is 9, x squared is x squared. Opposite, minus, a times b, so that's 4 times 3x, always positive, b squared. So that's 16. X cubed minus 7x minus 8. That takes us up here to 3-term trinomials. Always look for a GCF first. If this is 1, it's just easy factoring. If you have an a out here, you're going to do guess and check. Now, just as a reminder, if you want, those of you who had me, remember, those of you new to me, if you go to my videos and look up Unit 2 and the notes, there is a lesson on, I can't remember what it's called, alternative trinomial factoring, something like that. But if you want some other methods other than guess and check, because that frustrates you, on how to factor trinomials. That's a quick little lesson and some practice. So this one, since this is a 1 here, this is pretty much easy factoring. This has to be x times x to get x squared. We need factors of 8. So 8 and 1, 2 and 4. One's going to be positive, one's going to be negative to get that negative. And they have to have a difference of 7. Well, that's going to be 8 and 1. And since we want the 8 to be 7 leftovers to be negative, the bigger number has to be negative. X minus 8, x plus 1. On number 4 here, now we have some guessing and checking. Still, since this is a prime number, it has to be 3x times 1x. Now with the 8, it's going to be 8 and 1, 2 and 4. Again, here's where the guess and check comes in. Now the way I do it is, I suggest you do some little lines here, and then go ahead and fill in your numbers. So I'm just going to try 4 and 2. Well, 3 times 2 is 6, 4 times 1 is 4. And since this is a negative, one's going to be positive, one's going to be negative. Well, 6 minus 4 is 2, and 4 minus 6 is negative 2. That doesn't work out. So now I'm going to try 2 and 4. 4 times 3 is 12, 2 times 1 is 2. Now, 12 minus 2 does give me 10, and 2 minus 12 gives me negative 10. What do I want? A positive 10. Therefore, I want a positive 12. I follow the line, positive, negative. 3x minus 2 times x plus 4. Okay, now we are into some exponential practice. Remember, I'm going to come down here. My mantra is sign, number, variable. Instead of trying to do everything at once in your head, break it on down. So when I'm multiplying and keeping the base and adding the exponents, similar to what we did in logarithms recently, I'm going to worry about the sign first. Positive numbers, they give me positive answer. Then I do the number. 8 times 2, 16. Now I worry about each individual variable. X squared times x to the 5 is x to the 7. Keep the base, add the exponents. Y 7, and don't forget this is a y to the first, that's y to the 8th. Division. Simply cancel. 3 goes into 48 16 times. Now, technically what you do is you subtract the exponents when you're doing division, which makes sense. If you're doing plus, it becomes times, and division and subtraction go together, just like with logarithms. But the way I like to do it is a little bit quicker and easier, because that way you don't have to worry about negative exponents and then having to move them and save yourself some work. I just ask myself, where do I have more A's? Top or bottom? Well, the answer is bottom. How many more? 3 more. So it stays in the bottom. If I did it the traditional way, I would do 9 minus 12 and have 8 of the negative 3 on the top. And then I just have to say, wait, I don't want negative exponents. Go downstairs. B, remember this is b to the 1, which means I have b cubed upstairs. And c squared just stays. Done. Okay, 3x squared minus 15x squared, I am going to do the GCF and pull out 3, because that goes into 3 and 15, and then we'll look for the smallest exponent, common, x squared. That's what I'm going to take out. Now I'm going to divide. 3 divided by 3 is 1, x cubed, x squared, x to the 1. I don't have to put either one of those 1s, just doing it as a reminder. Negative 15 divided by 3 is negative 5, and the x squareds cancel, and that's my answer. Number 8, factor. Well, what can I take out of 12 and 30? I can take out 2, but I want to look for the greatest common factor, and that's a 6. I look for my smallest common variable, exponent. That's what I'm going to take out. Now I divide. 12 divided by 6 is 2, and the x squared cancel. Negative 30 divided by 6 is negative 5. X to the fourth divided by x squared is x squared. And that's it. 9x squared minus 49. Hopefully I recognize that everything is a perfect square. So I'm just going to do my shortcut. Square root of 9, square root of x squared, square root of 49. 1 plus, 1 minus. 6x squared minus 5x minus 4. I have to do some guessing and checking here. There's going to be 6 and 1, 2 and 3, 1 and 4, 2 and 2. It's going to be some combination of that. I'm going to start off in kind of split the middle, 2x and 3x. That will give me 6x squared. 1 and 4, that gives me 3, that gives me 8. 8 minus 3 is 5, but I want a negative 5. So the 8 should be negative, this should be positive. I got the 8 from here, so that makes that positive. Okay, rational expression. This is huge. Okay? You cannot divide by 0. If you type in any number divided by 0 in your calculator, you will get an error. So, number 11, we can't have 0 on the bottom, and it says, what can not be on the bottom? Well, if you factor y squared minus 9, you might notice that this is a difference of 2 squares. So y minus 3, y plus 3. So this part is huge, and I'll talk about this in class again a lot, because this leads to one of the most common errors all the time. So what I just did was I factored. Okay, I factored y squared minus 9 to y minus 3, y plus 3. Now the most common mistake here is people, don't write this down yet, will cancel, and then they'll say, okay, the excluded values are 3 and negative 3. But that is an error. That's the most common error. What you want to do is follow these rules. FEC. Okay? F-E-C. You want to factor first, then find your excluded values. So you're going to set this equal to 0 and get negative 7. This equal to 0 and get 3. This equal to 0 and get negative 3. So what are my choices here? I want plus or minus 3 and negative 7. Then, after I state the excluded values, I cancel. Okay, which would lead me to my final answer being 3y over y minus 3, y plus 3. So let's see how that's going to break down. We're going to factor the top, and it's going to end up being, let's see, B and B, and we're going to use 10 and 7. They multiply to give you 70 and differ by 3. I want negative 3 left over, so it's going to work out like that. On the bottom, I'm going to have close to the same thing. I still want 70, except I want 17, so they're both going to be positive. Now notice what happens. I end up with plus b plus 7 over b plus 7 cancels. So now I set the bottom equal to 0, and I get b equal to negative 10. So my excluded value is b cannot be negative 10. On the top here, I'm going to take out a 2, and I'm also going to look for the smallest exponent, n squared, and that's going to give me n minus 7. On the bottom, when I factor this, you get n minus 7 and n plus 5. Those cancel. Set n plus 5 equal to 0, and n cannot be negative 5. Because that would make the bottom, the denominator, a 0. And don't forget, I think I mentioned on the previous video, but if you have trouble with factoring, you can go to my videos under Unit 2, and it's called Factoring Trinomials, Alternative Methods, or something like that. So go ahead and go there if you have any difficulties or want to practice some other methods besides guess and check. Okay, to simplify, we're going to factor and then cancel. So on the top here, we end up with one of two choices, actually. I want to talk about that. So I'm going to factor the bottom first, and I'll tell you why. The bottom is going to end up being x minus 2, x plus 1. Now, if I pull out a positive 4 on the top, I'm going to get negative 1 minus x. Now notice nothing cancels, because negative 1, negative x is not the same as x plus 1. So if I, instead of pulling out a positive 4, pull out a negative 4, then I end up with 1 plus x, which is the same thing as x plus 1. And therefore, that cancels 1 plus x and x plus 1. Now you won't write it 3 times. I'm just showing you that 1 plus x is the same thing. But sometimes the first number you pull out will not be the best number. You might think, hey, I want to get, just pull out a 4. Okay, that's fine, but it doesn't work out. And now, we only have x minus 2 left on the bottom, so what can x not be? It can't be a positive 2, because 2 minus 2 is 0. Okay, number 15. Here's a hint. I bet you we're going to have an x plus 1 on the top. Why? Because that's the lesson, that's what we're practicing. So I'm going to pull out a 5, and I'm going to get x squared minus...
This is your reminder the activity.
Okay, so I have 5x squared minus 5. I pull out 5, I get x squared minus 1. I did not end up with an x plus 1. Except, wait a minute, x squared minus 1 is a difference of 2 squares. So I can break this down further to x minus 1, x plus 1. Now, I have 5 on top. I have a 5 times x minus 1, and that's it. There is nothing on the bottom, so there are no excluded values. X can be any number in the world, and it'll be okay. Okay, number 16, I'm going to factor the top, factor the bottom, and I'm going to get x minus 2, x minus 2 on the top. And at the bottom, I will get 2x plus 1, no luck there, and x minus 2. Cancels. So I set 2x plus 1 equal to 0, minus 1, divide by 2. X cannot be negative 1/2. And last but not least, number 17, I'm going to factor the top, and it's going to be 2x plus 1 and 3x plus 1. On the bottom, I'm going to factor 3x plus 1 and x plus 1. 3x plus 1's cancel. That leaves me an x plus 1 on the bottom, which I set equal to 0. So x cannot be negative 1. That's my excluded value. And there's the end of the notes.